Yeah, good afternoon, everybody. There is a slight change in my schedule. What I intend to do today is cover more of, the standard temporary library usage. Last time, I think so. Faisal, you wanted me to cover usage of vectors and maps in real application scenario. We'll explore that a little bit more, and from Monday we'll start data structures.
Okay.
Yeah. So let us begin. I have taken the example of a bank and its branches. Is my screen visible?
Yes, sir.
Yeah.
Yes, sir.
Okay. So let's build a class branch where you have branch name, IFSC code, area name, city, and we have the regular constructor and one getter here because we need to get the IFSC code while you want to search the branch based on the IFSC code, and there is a display which will display all the fields of the branch. Now, how do I use a vector in this application? So as you all know, bank has many branches. So to model a bank, we can include as member the bank name. Then we can include bank type, whether it is a private bank or a public sector bank. These are the two data members, and here we can have as vector of type branch all branches. Okay, so we will not know in advance how many branches will come up. So what we can do is we can just have a vector of branches, and you can add the branches as and when the need arises. All right. So in the public section of this, we can have the constructor for the bank, where I'll initialize only the data members, bank name and bank type. Then bank type. Now you want to add branches as and when required. So we will have one method add branch, and this requires a branch to be passed as an argument. We can use a reference variable here, and to add to the branch, it's all very simple. You just say all branches dot push back and specify this. Okay, so this is the simplest way of adding a branch to the bank. Now if you want to display all the branches as you go on adding, you can have show all branches. And we can have a for range loop where you can say branch ampersand b colon all branches, and just b dot display. So display method anyway we have written, just call this display. Okay. Now there's a we can add more methods also, like if I want to insert after certain position, so you can say insert branch after. You can indicate the position and then send another branch. So add branch will always add it to the end of the list, but if you want to insert a branch after a position, given position, you can do like this. So the way to do that is you can use an iterator. Then you can say all branches dot begin. and if you want to insert at a particular position, insert branch, insert, then you can take this iterator plus the position that is received and then specify the branch. So this will insert the branch after the given position. If position is 1, after the first branch, second branch, the new branch will be added. So this is given a position of the existing branch, after the branch the new branch will be added. So this is how it can be done. Alright. So these are few of the methods you can have. Like that you can go on adding different branches from the list. So another method would be, let me just check what method I have added here. Insert branch, show all branches. Okay. Now suppose if you want to find a particular branch and display. So you will have, once you find the branch, you have to return that branch. So the return type will be branch star. And here you can have find branch. And you have to pass as argument the IFSC code, because I will be searching based on the IFSC code. Okay. So since it is an array of objects, so you can iterate through, or you can use auto B like this, and all branches, and you check if b dot get IFSC is equal to whatever IFSC code that you have received. It means you have found the branch, isn't it? So here you just have to return star b. Return ampersand. You have to return the address of the branch. So that, and if you are not able to find even after iterating through, then you just have to return a null pointer. Okay, because what might happen is the IFSC code that you specify may not be there in the all branches list. Okay, so these are some of the methods you can add. As you can see, everywhere I am using the vector all branches to perform these actions. Okay, while adding a new branch or showing all the branches or inserting a branch after a given position and then searching for a given branch based on the IFSC code. Okay. So the first thing that you would do is create a bank. So bank, let us say HDFC Bank. Now we need to specify two arguments, the name of the bank, say HDFC, and type of bank, it's a private bank. Okay, so once you create an instance of a bank, you can use its methods. HDFC Bank. Now if you want to add a branch, add branch. So before this you need to create the branches. So before this I need to create the branches. So branch B1. So it expects different arguments here. So if you look at the definition of a branch, it has a branch name, IFSC code, area name and city. 4 arguments you have to pass, all strings. So branch name, let's say Venus branch, some branch. Then this is a IFSC code. So let us say HDFC 000176, something like that. Then area, let us say, then city. So let me create a couple of branches here so that we can experiment with all the methods of the bank. We have to rename as B2 here, B3 here, maybe B4 here. Some branch names. So IFSC codes, you can keep them little different. Let the city be same. Okay. So if you simply want to append it to the array list or your vector, you just have to pass the branch. So first branch is added like this, and then if you want to add one more, you can do that, add branch. And let us display only these two. So you say show all branches. So right now it should show two branches added to the bank. So let's see it goes through the result. Okay, so we have two branches added here. Alright. Now if I want to insert a branch after B1, then here I can say HDFC dot insert branch after 1 and let us say B3. Okay, so in between these two, certain branch should be inserted. So let's see whether it goes through like that. You can see after the first branch, second branch is Saturn and third got shifted. So you are able to insert a new branch in between the two. Fine. And finally, if you want to add one more branch, just add branch and say B4. Okay, so you understood how to add new branches to the bank. Alright. Now if I want to search for a particular branch and display, here I am going to say branch star br, because that find branch is going to return a pointer to a new branch. Then I should be saying HDFC bank dot find branch, and I have to pass the IFSC code as string. So IFSC code of one of these is, let us say, HDFC 000 174. We shall try to find out. Okay. And once you get the branch, you can display the branch details. Okay. So you can say cout the branch found is. So instead of handle, you can put a slash, and so in one statement you can have that too. Okay, so branch found is HDFC 174 Nagar. So you can look through this, it is a Saturn branch. Okay, so we are able to perform all the operations successfully by using a vector to store all the branches of the bank. Similarly, in each branch you can have accounts. So you can have a account class, and use a vector to store all the accounts and do similar things like add a new account, add an account after certain position. Okay, list all the accounts, based on the city of the customer or city of the branch. Likewise, you can add. Okay, so all those modifications are possible. Okay, so did you follow what we have discussed so far? Hello.
Yes, sir.
Okay. So vectors are useful. See, I'm not pre-allocating any memory. I'm just saying vector, branch, and all branches. Automatically it grows. As you add more branches, it will keep on growing in an exponential way. All right. Now, what if I want to use a list instead of a vector? That should be possible, right? Vector, as you all know, it's a array basically, but dynamically the size is incremented uh, exponentially or in a quadratic way. That is, the size of the vector will be doubled every time you reach the capacity of the vector. Okay. Now, one problem with vectors is that if you are inserting in between too often, now normally if you are inserting at the end, there is no problem. If you say pushback and using pushback most of the time, this program works perfectly fine. But if you are inserting in between all the time, as you know, vector is a normal array, the elements have to be shifted. Okay, so if the size of the vector is very large, let's say 100 branches are there, and if you are inserting somewhere after third position or fourth position, lot of branches have to be shifted, so that is going to take lot of time. Okay, so to avoid the overhead associated with insert, instead of a vector you can always use a list. Okay, only thing is, instead of hash include vector, you should include list here. List, as you know, it's a doubly linked list, and insertion is very easy in doubly linked list. Okay, so are there any changes to be done? We have to see. This insert after needs little modification, because you see the iterator plus position, this is not going to work. Okay, so all other things would remain the same just for this one, because you cannot move the pointer like this, right? What you have to do is you have to use an iterator here, auto iterator equal to next all branches dot begin comma position. So as a result, what happens now, it is correctly positioned. All that you have to do is just say, okay, so this is the only change that is required if I want to switch from vector to list. Okay, so this would be more efficient way of implementing an array of branches in a bank. Okay, so let's see whether it goes through and gives you the correct answer or the same answer was you got in the previous example. As you can see, the output is exactly the same as you got in the previous case. So with very little change, you can switch from vector to list. Okay, so we are not able to use same syntax in insert branch after, because you cannot position the iterator wherever you want using with plus operator. You have to use the next operator. Okay, because it is a linked list, it has to be moved step by step. So this next function will position the iterator to appropriate location, and then it will help you to insert. Okay, so these are the few changes that you must note. Okay, would you like to try this out?
Yes, sir. Yes, sir.
Okay, just give a try. Let me keep it vector only, and then you can try this list part. and this let it be vector. So first try with vector and then we'll see how to convert this into list. Okay, so first part is b1 dot get ifsc comma b1 because key value pairs have to be passed to insert. Similarly here b2 dot get ifsc comma b2. All other things remain the same. If you want to add b3 also, then this has to be add branch. So these are the changes you should make, and now if I run the program, hopefully it should. As you can see, it is working exactly the same way it was working for list and vectors, but the difference is if you are frequently searching for a particular branch, normally you do, because given a particular branch you want some customer list or something like that, then if insertion and other things are done frequently and search is done frequently, it is better to go with map implementation rather than a list implementation. So did you follow the application of all the three standard template libraries for a given application scenario? So I'll share the source code of this with you, and then you can check with what modifications you have to do to get the map working. Is that okay?
Yes, sir. Okay.
Okay. A few more small points remaining that I told you. There are many synchronization methods. I think so. We know that ask me, are there any other ways of synchronizing the threads? So in fact there are 3 or 4 different types of synchronization mechanisms. So there is one synchronization method called as atomic synchronization. Let's say you have 2 threads and we have a counter like this. Okay, int counter equal to 0, increment counter, and this loop is going up to, let's say, some 50,000 and incrementing this. And if 2 threads execute, we expect at the end of execution of the main, the counter value should be 1 lakh, because this thread 1 is incrementing from 1 to 50 and thread 2 will be incrementing it again from in between, that number will be pushing towards 1 lakh. So let's see whether we get the correct result here. As you can see, the number is way below 1 lakh. The reason is there is no proper synchronization between the threads. The count which is incremented by thread 1 is overwritten by thread 2. Let us say thread 1 is incrementing 1, 2, 3, 4, 5, and thread 2 also starts with value 1 and goes up to 1, 2, 3. It will overwrite that 5 by 3, and again thread 1 when it resumes, it will get value 4, 5, 6, 7 like that. So some of the values which are counted by thread 1 will be missed by thread 2 or thread 1. Likewise, they miss lot of counts and you get a value much less than what is expected. Okay. Now to prevent this, you use a synchronization mechanism called atomic. Just include the keyword atomic and include this header file atomic here. So now the counter is locked when thread 1 is incrementing, and it will be opened only after the proper synchronization is done. Now you expect main ends here with 1 lakh value, as you can see, right? So if whenever you have a scenario where 2 threads are competing for the same resource, you can use this synchronization mechanism, which is much simpler than the locks, mutex and all. Okay, so this is one mechanism for this. Did you follow this?
Yes.
It's pretty simple, right? Okay, now another thing is you have a thread which is taking too much time and you don't want main to wait, it wants to continue. In that case, we have to use a synchronization mechanism called as future or promise. So let's see what this is. Here I have taken an example of compute sum. So you are going to simply add two numbers. So you create a thread, okay, and this thread will be running compute sum. It will taking 7 and 4 and do that. So what you have to do is the result, instead of just declaring int, you have to say future in angle bracket int and result. As you can see, they all resemble like templates, right? So basically this future and atomic are all templates. Okay. So use a future template and declare result as of that type, and use a function called as async. So this async means what? This function, when you execute, this compute function start executing as a thread. Okay, and this thread will be doing some work here. Let's say it is taking 2 seconds to compute a plus b. Of course, it will instantly do that. Deliberately, I am introducing 2-second delay here, so that the main will not be blocked until your compute sum completes. The main thread will continue. Like cout main is doing its own stuff. Then main may introduce some delay and do something else. And whenever you want the result computed by compute sum at a later stage in your main, you can use result.get, where result is a future variable, and only when you say result.get the value becomes available, even though it is computed and kept ready. Okay, so this function will be available, its result will be available at this stage. So if I run the program, you will see that both the thread and the main will coordinate among themselves to get the values appropriately. So just observe what output you get here. See, main doing is its own stuff. Again, took 2 seconds to compute, so that addition is done. So got result compute 11. So 11 is got at this stage. Okay, so the main is not blocked, right? The main can continue executing even when the child thread, which is created through this launch async, will be doing its own stuff. If you let us say this hypothetically adding two numbers take 10 seconds, so main need not wait for 10 seconds, right? Alright, so that is how the synchronization is done. That is, the thread is allowed to continue and main will allow to continue if whenever main requires the result of computation of the compute sum, it can call this result.get and continue further doing its own stuff. Okay, so this is another way of synchronizing the main thread with another child thread. All right, and then there is a third one, that is semaphore. Now semaphores are for utilizing resource. How many threads can simultaneously access a particular resource? For example, there is a printer, okay, and how many printer instances are there? Suppose there are 2 printers and 5 processes. So the maximum resources available are, you can specify. As you can see, counting semaphore, max permits, that is a template again, and you declare a semaphore variable with max permits. Like here in this case, I am allowing 3 threads to access the resource simultaneously. So in my main, I'll be running a loop to add, let us say, some 8 worker threads. So as you can see, I'm using vector, and the vector template I'm passing thread. So I'm creating an array of threads, and as we have seen, emplace back means it's going to create this worker thread and start executing. So there will be 8 threads which will be competing to use the semaphore here, and whichever thread gets the access will use the semaphore, and before it wants to use the semaphore, it has to acquire. As you can see, there is a method called as sem.acquire. Only after this the thread can use the semaphore or send a print command to the printer. Okay, so the print starts happening. But if all the printers are busy, then other threads, even if they try to acquire, they have to wait. Okay, and once the printer which is occupied by a particular thread, if it is done, it has to release it. So there are two steps here: semaphore dot sem dot acquire and sem dot release. So these are important steps that must be performed by the threads which are competing to acquire the resource. So appropriate coordination happens, and you will see working of this. Only problem with semaphores is it is not supported in C++ which are below version 17. So in my system I have version 15, so it is showing some red line here. If you want to check that, you can go to online GDB, where I am using the compiler C++20. The same program will execute perfectly fine. So if I run this, you will see in the output. Okay. So thread 2 waiting to enter, thread 2 enters critical section, it gets the semaphore. 3 also waiting, it enters. 1 waiting to enter, it gets a critical section. Now as you can see, all the 3 semaphores are busy. 4, 5, 6, 7, 8 threads are all waiting. So they cannot enter until one of them releases. As you can see, if you go down this list, thread 1, 2 leaving the critical section. Okay, so 1 and 2 if they leave, 3 is leaving, 4 will enter the critical section, and some other thing is leaving, thread 7 entered, like this. So the common resource will be appropriately utilized by the competing threads. So this is very useful whenever you have a common resource, and you can decide how many instances of that resources are available using the maximum permits here. If you have 3 printers, this value should be 3. So this scenario depicting 8 processes trying to print their documents on 3 printers. So nowhere they mix up their data. Okay, so it shouldn't happen that process 1, when it is printing, process 2 also prints to the same printer. Okay, so until the printer is released, other process has to wait. Okay, so you will see that at the end of your program, all processes will print their documents correctly. Okay, so this is one very useful concept which you should be aware of, and in fact it is part of operating system. If whenever we visit the concepts on operating system, I'll be discussing semaphores. Alright, I'll share this program also, and you can have a copy of this and experiment and see how the things actually work. Alright, okay. Any questions in today's session? Hello?
Nothing from my side.
Okay. Things look little difficult because I haven't covered the operating system concepts yet. We shall do that whenever we visit that last part. Okay. So is it okay if I start data structures from Monday?
Sir, you're breaking, couldn't hear properly.
Okay.
Yes, sir. Your voice is breaking.
Let me reconnect once again. Just 1 minute.
Sir, now it's okay.
Is okay, no? So is it okay if I start from Monday data structures? Are you comfortable now with C++? Hello? Your voice is not coming.
Sure, sir.
Okay. So from Monday we'll begin with data structures. Yeah.